Let us understand another important residual technique called the influence plot. So, what is an influence plot? An influence plot is a diagnostic tool used in regression analysis to identify and visualize the impact of individual data points on the fitted regression model. It helps in detecting points that have significant influence on the model coefficient that can affect the validity and robustness of the regression result. There are basically two key metrics in the influence plot. The first is the leverage. It measures how far an independent variable's value is from the mean of independent variable values. Higher leverage points are those that have extreme values of the independent variable. So basically what leverage is that? Leverage measures how much a data point can influence the fit of regression line. Think of it as the power a data point has to pull the regression line towards itself. Let us understand it from a simple analogy. Imagine you have a seesaw and the data points are kids sitting on it. A kid sitting far from the center has more leverage to tilt the seesaw compared to a kid sitting closer to the center. In this analogy, the further away a data point is from the average value of the predictor variable, the more leverage it has to affect the regression line. So does it matter, you ask? Higher leverage points are those that are far from the average values of the predictor variables. They have the potential to strongly influence the slope and position of the regression line. The second metric in plot is the studentized residuals. They are the residuals, which is the difference between observed and predicted value, which is scaled by an estimate of their standard deviation. They help in identifying outliers by accounting for the variability of residuals. So basically, a studentized residuals are a way to standardize residuals to make them comparable. They tell how far off a particular data point is from the predicted value, accounting for the variability of the residuals. Let us understand it from a simple analogy. Imagine you are comparing students' test scores, but you want to account for different difficulty level of tests. A student's performance is then compared to how well other students did on similar tests. Similarly, studentized residual adjust for how much wiggle room is there in predicting the test scores so that you can better understand if a particular score is unusually high or low. So does it matter, you ask? So basically studentized residuals helps identify outliers like the data points that don't fit in general pattern. A large studentized residuals means that data point is significantly different from the model predicts. Now let us look at the code. So we will be following the same procedure as for the earlier two residual analysis technique. We are importing the library, we are loading the data set, we are splitting the data set into train and test, and then we are performing the OLS. And then this is new. We are plotting the influence plot. So basically, this is a part of this library stats model. So if you call this function, we will get this plot. So at x-axis we have the leverage, and at the y-axis we have the studentized residual.